We are just about ready to finish up our introductory model here. As we've seen in the last videos, we are generating our honeybee rooms and adding some fresh air ventilation systems, domestic hot water systems, configuring the model, and then exporting all of that out to the PHPP. And at this point, we're getting some pretty good results when it comes to things like our annual heating energy demand, our annual cooling energy demand. Those sorts of demand level results are all flowing through into our PHPP. We've configured the PHPP with the number of occupants and the types of certifications that we're after in our last video. And our last piece of the puzzle here, our last main piece, in order to get a full set of results, is to build out the heating and the cooling systems for the building. So those two pieces are not going to affect your heating or cooling energy demand, but they are obviously going to be really important when it comes to the question of how much site energy or purchased energy your building is using. And then, of course, that's going to be critical when it comes to calculating your primary energy for the building. So in order to round out our set here, let's take a look at what it's going to take to model our mechanical systems, our heating and cooling systems for our little example model here. So if you've been following along in the videos, you should have something that looks roughly like what's on the screen here. We have our Rhino model of our building, and then we are building out our second floor and first floor thermal zones. Remember, we call those honeybee rooms now in the new version of Honeybee. We are adding some PHPP spaces to those rooms. The rooms are, we have one room for the top floor, one room for the bottom floor, one zone for the top floor, one zone for the bottom floor. And then we add some individual spaces, some volumes inside of those. We added some TFA, added some volume information, etc. And then on top of that, we added some system level information. We added a fresh air ventilation system and a domestic hot water system. All of that then flows into our configuration. We configure the model, set it up as we like, and then export it to the PHPP. So how are we going to add our heating and cooling systems to this structure here? Well, it's going to work very similar to the fresh air ventilation or the domestic hot water. We're going to have some dedicated components that we're going to use to configure those systems. We're going to add those systems to our honeybee rooms as they flow along in this link here, or in this chain here. So I'm going to come into my Grasshopper scene here. We're going to be working mostly in Grasshopper, so let me maximize that. We're not going to need our Rhino window for a little bit. So I'm in my Grasshopper scene here, and I'm going to come up to my Passive House Tools ribbon. And in the Passive House Tools ribbon, let's just take a look for a second. If I come over here to this O1, and I go to O1, notice down here at the very bottom in the last section, we've got a whole bunch of components dedicated to heating and cooling system setup. So for instance, we've got a couple different types of cooling, dedicated dehumidification systems, panel cooling, radiant panel cooling, recirculated air systems, very typical air conditioning system, and then supply air only cooling systems, so providing cooling riding on the fresh air ventilation. Notice also here that we've got a couple of options for heat pump systems for heating, and then that's about it at the moment. So this is one of those sectors of the Passive House Tools and the Ladybug2PH toolkit, which we're actively developing. So keep your eyes open for additional heating and cooling components in the future. Things like boilers and district heating and all of that kind of stuff will come eventually. But at the moment, you have the ability to just build out some simple electric heating and cooling systems. So those are the only elements that we're able to build out at the moment. But as I said, we are actively developing that, so we'll have some more in the future for sure. Notice also at the very bottom there that we have a single component named set systems. So we have a whole bunch of individual system types, and then what we're going to do is we're going to set the honeybee room systems using that last component there. So what I'm going to do is I'm going to come in here to this set systems component, and I'm going to drop that onto the canvas just anywhere for now. And let's zoom in and take a look at what we have in this new component here. So this is how we're going to set up our heating and cooling systems. Notice first of all that it's going to take in some honeybee rooms. So this component takes in individual honeybee rooms, one or more honeybee rooms. You can have multiple different system types applied to different rooms in your honeybee model, and then it's going to take in various different types or options, different types of equipment that'll then get applied to those rooms, as well as some configuration elements up at the top there. And of course, all of this is going to strongly mirror the PHPP. The whole point here is to configure the PHPP in exactly the way you want. So things like primary heat generation and secondary heat generation, you'll recognize all of that lingo from the PHPP. So in order to get this working, in order to get this operational, it's really quite straightforward. We don't have to do anything more than simply input the honeybee rooms and then use those honeybee rooms that come out of the component, which have had some modifications applied to them. So let's do this. I'm going to come up here and I'm going to make some new space. So we could put it pretty much anywhere we want. Let's put it here. Let's put it here after our after our domestic hot water. Should we do that? Well, let's put it, actually, let's do this. Let's put it over with the other mechanical system. Let's keep our domestic hot water last, and we'll do this. We'll keep it with the fresh air ventilation system. They're sort of cousins, kind of, right? Mechanical systems. So we'll do this, and we'll call this heating, cooling. Oops. Okay. And as I said, it's really quite straightforward. All we have to do is take in some honeybee rooms. So we've got honeybee rooms coming out of our ventilation system. We'll go ahead and feed those into our component here. And then all I need to do is take the resultant honeybee rooms, which is our first floor and our second floor. They've had some new elements added to them, and just pass those along to the next link in the chain, which happens to be this domestic hot water guy here. That will then feed into the rest of our model. Now, we don't need to do anything else at this point, but let's just take a minute and see what happened to our PHPP. So let me come over here, and I'm going to turn on my PHPP, and we'll go ahead and write this out to a PHPP, and let's see what it looks like now that we've updated just this one component, now that we've added just this one piece. Okay, so that's all written out, so let's take a look at our PHPP here. It's double stud wall. What do we have? Let's go to our verification worksheet, first of all. So we were working in the verification worksheet last time. We saw how we could set up our dwelling units and our certification type, etc. And notice now we're getting good heating demand numbers. We're still not getting any cooling demand numbers. We'll talk about why that is the case in a bit. We are getting a very high frequency of overheating. And then notice down here we are finally getting some real numbers for primary energy and primary energy demand. They're bad numbers, they're very high numbers, but we'll talk about why that is the case, right? Our targets are listed over here. So for pass-pass certification, if we have a target of 120 kilowatt hours per square meter per year, we're currently getting a result of 242. So we're fully 100% over the passive house targets here. Now, why is that the case? Well, let's see what the heating and cooling system just did to our model. So I'm going to scroll all the way down to the bottom here. I'm going to scroll all the way to the end, and I'm going to go to this primary energy renewables worksheet. So let's take a look at this PER worksheet, and let's see what has been set up by our heating and cooling component. So this is our primary energy worksheet, and notice here what our component has done is, by default, because we haven't given it any other information, it's going to set up a simple direct electric heating system for both heating and for domestic hot water. Notice 100% of the heating comes from direct electric, and 100% of the domestic hot water also comes from direct electric. Well, no wonder our primary energy is so high. That would be a terrible way to heat and create hot water for most projects. Certainly economical in first cost, but terrible in terms of operating costs, and certainly terrible in terms of primary energy, old-fashioned primary energy for sure. So, okay, but that's the simplest system. So everything's working. It's all set up and working. Now what we need to do is just configure it the way we want. So for instance, we're probably not going to use direct electric for our heating. If this is in a cold climate, if this is in a place like New York, we're probably going to use something like an electric heat pump. Right? That's going to be how we're going to provide heating, cooling, domestic hot water, and dehumidification in most of the modern passive house style all-electric buildings that we're building. And so let's go back to our grasshopper scene and see what we can do about modifying this so that we're not using direct electric. Instead, we can use or set up some heat pump systems. Okay, so I'm going to leave that on, and we'll sort of take a look at it as we add some modification elements. Let me come over now. I'm scrolling over, and let's go back to our heating and cooling system. And first of all, let's talk about adding a heat pump for heating our building. So our primary energy is far too high, and one of the things that we could do to bring that down would be to use a heat pump system. So how are we going to build out a heat pump for our heating? Well, notice here that we have the ability to input a heat pump for the heating system. We also have the ability to input a heat pump for the domestic hot water system, and then we have these guys here representing typical air source heat pump systems. We have the ability to input ground source heat pump systems, and then there are some options for the heat pumps as well. And so we'll take a look at all of those guys in addition. I should also note these elements down here, boilers, etc. Notice I guess we don't say it here, but these are not yet functional, so they will be soon. Maybe by the time you're watching this, you'll be able to, you could enter district heating and boiler, fossil fuel boilers, that kind of thing. I haven't built them out yet. Here I'm recording this in February of 2021, but hopefully those will be up and running soon. We'll have those. In any event, let's use a typical air source heat pump for our project here. So what am I going to input into this heat pump heating element here in order to add a heat pump to the system? Well, I'm going to come up here to my O1 model, and I'll come over here and come down to this air source heat pump. So I've got two. I've got an air source heat pump itself, the piece of equipment, and then I've got some configuration options for that heat pump. So a couple of different elements here that we can take a look at. But let's just start with this air source heat pump equipment itself. So let me just drop that onto the canvas. So this is a piece of heating equipment, and it's going to take in some inputs here, things like COPs and names, and then it's going to kick out a heat pump. That heat pump will get connected here to our heat pump heating. Okay. So let's get that set up. Let's just take this guy. Let's see, actually, I don't remember. Do we get a default heat pump? We do. Okay, so we have a default heat pump here with some default performance information, a default name. So let's just see what happens when we take that heat pump and connect that to our heat pump heating input here. So this is just a totally default heat pump, the kind that would come preloaded into the PHPP. So no custom values yet. Let's see what happened to our PHPP. So let me go back to the PHPP, and let me maximize this. And our primary energy is still at 242. So what happened? Nothing happened. Yet notice down here, all of our heating is still coming from direct electric, 100% coming from direct electric at a COP of 1. All right, so not very good. So why didn't that work? Why didn't our heat pump flow through? Well, remember, in this worksheet, we need to say up here at the top, what is the source of our heating and domestic hot water? So we have successfully added a heat pump to the PHPP. We'll go look in a minute. The heat pump worksheet now has a new piece of equipment, but we haven't really said, oh, we're going to use that for anything. Right now, the PHPP still thinks we're using direct electric for everything. All right, so how are we going to set that? Well, it's pretty straightforward. All we need to do is come in here, and we just need to set up the type of primary heat generation. And notice here that the heat pumps are number 2 on our list. So we have a list of allowable heating system types. By default, as I said, as you've seen, we're going to use system number 5, direct electricity. That's the simplest. It doesn't really require any equipment configuration. It just assumes a COP of 1 for everything. But we're going to use number 2, heat pumps. So let me just input that. I'll just say 2 heat pump or heat pumps. We can have as many as we need in the model to provide enough capacity. And as soon as I hook that guy up, so that gets hooked up to primary heat generation over here. Let's go back to our PHPP and see what happened. So notice now that we are now setting the type of generation to number 2, heat pumps. So 100% of our heating is coming from heat pumps, and 100% of our domestic hot water is coming from heat pumps. And notice down here that under heating, all of our consumption, 100%, shifted over to heat pumps at a COP of like 1.59. So better than 1, but of course we can do better than that. But this is just the default heat pump that comes in if we don't give it any other information. Notice already our primary energy has dropped to 120. So that's great, right? We went from 240 down to 120 by just using better equipment to supply the heating and domestic hot water. If we were to scroll down a little bit, notice domestic hot water. Domestic hot water is also coming from our heat pump. We'll talk about why that error is coming through. We need to do a little extra configuration there for that guy. Okay, so this is working though. We've got our heat pumps working and flowing through into our PHPP. Let's do this though. Let's say that we want to use heat pumps for our heating, and then we want to use direct electric. Let's say, for purposes of argument, that we want to use direct electric for our domestic hot water. We have some like on-demand direct electric system or something like that for hot water, which obviously wouldn't be a great idea, but just to show that we could do it, right? So we can set up direct electric for our secondary type, heat pumps for our primary type. Notice that we're still getting a little bit of an error, and our domestic hot water is still assigned to the heat pump. So what do we need to do to change this? To come in here, and we need to say that the domestic hot water fraction of the primary heat generation is going to be 0%. So 0% of the domestic hot water comes from the primary heat generation source. I know that's kind of a confusing way to do it, but that's how the PHPP is set up. This is where you input. You say what percentage of the heating comes from your primary source, what percentage of your domestic hot water comes from your primary source. If you put in 0, then what that means is 100% comes from your secondary source. I know it's kind of a weird way to enter it, but like I said, that's the way the PHPP works. So in any event, we can have multiple heating generation equipment, multiple heating generation sources in our project, and this can all flow through, and we can obviously then configure these various systems to our heart's content. So let's take a look. Let's go back to our verification worksheet, and let's see where we're at now. In terms of our total, we're back up to 217. So using direct electric for our domestic hot water kicked us way back up to over 200. So maybe we would want to use a heat pump for that, or obviously we would want to use a heat pump for that. So in any event, when we come back in the next video, we will take a closer look at these heat pump systems. So we'll look at some of the configuration options. Maybe we'll add a second heat pump for our domestic hot water system, and we'll talk about how we're supposed to set up the details of our heat pump systems, because as of right now, we're just using the default performance values for our air source heat pump system. So we'll come back in the next video and take a look at all the details of our various heat pump systems in the PHPP.